Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of linear relationships. This is standard 8.5C in the great state of Texas, and we are using item number 40 off the 2018 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got 4 different scatter plots here, and we want one that does not suggest a linear relationship between x and y. We don't have any of the lines actually, or any of the points actually plotted for us. We don't really need to. So there's going to be 2 words here in our very brief question that are going to give us a hint. First is going to be that word linear. So we need to understand what the word linear means. And so if we just write it down here, even though it's pronounced differently, take a look at this word in there, line. So when we go from line to linear, obviously we're changing the vowel sound, but that word is spelled right at the very beginning. So we're looking for something that does not show a straight line. So just when you're thinking of linear, think of a straight line. And then this word is also going to be helpful, suggest. So it doesn't have to necessarily show a straight line that's 100% perfect. Suggest kind of softens it a little bit, like it hints, or it's kind of like a halfway, like you would put something like approximately or an estimate, right? It's not going to be 100% perfect. It's going to hint at a linear relationship. So how do we get linear relationships? So remember, we've been working with 2 different linear equations for a good chunk of our 8th grade year. So we get linear relationships when we use the slope-intercept form. And we also get linear relationships when we use direct variation. And remember, the only difference between these two, even though one is with a k and one is with the m, those are both slope, it's the fact that our k is proportional. It goes through the origin because it does not have a y-intercept like the slope-intercept form does. That's really the only difference. But those always give you straight lines, whether it's slanting up, whether it's slanting down, because it's just got a single variable and there's no exponents involved. That's what messes you up, is when you get an exponent involved. You might get more than one variable. That makes your graph gets all kind of wavy. But we're not looking for that. We're looking for straight lines. So let's look at F. And since you got these kind of clustered together, what we're going to do is we're just going to try to draw in between. So that's as close as we can get. It looks pretty straight. It might have a very, very slight downward slope. It might just be a straight side to side. But that looks pretty straight. And so we're obviously looking for the one that does not look like the others. And so this G here, trying to just kind of draw it between everything. Not 100% perfect, didn't quite capture that one. But for the most part, you see that looks like a straight line. I didn't want to just hook it straight down. This is pretty clear right here. H. Look at that. That's a straight line. So you see we've got 3 different straight lines, 3 different linear relationships, and then one of these is not like the other. So even if we didn't understand what the word linear is, if we draw these trend lines, you can see, all right, I'm going to choose the one that is not like the others because it starts out pretty decent and then it just takes a hard hook down. Definitely not a linear relationship because it's got that big bend. So our answer here is J.